All right, so what we've been talking about so far is what we call the disk method, and that is for finding our volumes. Um, and that is based on circles, so slicing things into these disks and finding the area of all of those circles added together. So pi r squared, just the area of a circle, that's the disk method. Now, something else happens that requires us to adjust that a little bit, and I want to show you that right now. Example 3, we have y equals the square root of x and y equals x squared. We want to take the area bounded by those two functions and we're going to revolve it about the x-axis. So square root function starts at 0, 0, goes to 1, 1, looks like this. And then y equals x squared, of course, that's a parabola. I'm not going to worry about the side of the parabola because it's only going to be bound over on this side. So yes, the parabola goes this way, but I don't really care about that. All right, so we want to take this region and revolve it around the x-axis. So let me get rid of those so we can see what's going on, okay? So we're going to revolve that around the axis. Imagine spinning that. It helps if you kind of draw it down here too. Okay. And so you get this shape, kind of a half sphere, but it has a hole in it, like a Hershey Kiss size hole. Okay, so, or you can think of it as like a bowl, but then the inside of the bowl is kind of curved like that. So it is still a solid, but there is space inside of it. Okay. So when we do this, we need the washer method. Washer comes from the fact that when we slice this into all of those different discs like we were doing before, instead of a solid disc, this is a circle that has a hole inside of it actually. Okay, so see it has this little hole inside of it. And that's where the name washer comes from. Okay, so like thinking like a tool. Now this is not a tool. This is from one of my children's board games. But this is what all of those look like. So we slice this into a bunch of different discs, and they all have a hole in them like this. Okay. So we need to adjust this. We still need to find the area of all of these little circles, but we have to account for the fact that there's a hole inside all of them. So to do that, the washer method is still pi r squared. Just broke that chalk. This is the dead spot in my chalkboard. Oh my word. Okay. So we're still doing the integral from a to b, but what we need to think about is the outer radius and the inner radius of this. Okay, so we are going to take the outer radius squared, call that rx, minus the inner radius, and I'm going to call that little rx. Okay, that's the outer radius. Yeah, this side of the chalkboard just doesn't want to write right now. And we call that the inner radius. Okay. All right, so we'll take a look at how this works in example 3. Okay, but this is the washer method, and it happens when you have holes. All right, so to do this problem, we need to find volume. It's going to be pi r squared. So when we slice this, we have a horizontal axis of rotation. When we slice this, all of our discs are in the x direction, so our problem is going to be dx's. And we want to think about each individual washer that we have in here. Remember, they're washers because there's that hole inside of them. So the outer radius is defined by this function. That is the square root function. So our outer radius is the square root function squared, minus our inner radius here is defined by the parabola, which is x squared. Okay, so outer radius defined by that function, inner radius defined by the inner function. Another way you can think about this, if you think back to 7.1, top minus bottom, okay, same thing, except you have to square them both. All right, so let's finish at this. Oh, we forgot from where to where. 0 to 1, obviously. Okay, so we're going from 0 to 1. Square root of x squared is x minus x to the 4th. And then we're going to take the antiderivative. We get 1/2 x squared minus 1/5 x to the 5th. And we are evaluating that from 1 to 0. So we still have pi. And we get, when we plug in 1/2 minus 1/5 minus, we plug in 0, we just get 0, so it doesn't really matter. So 1/2 minus 1/5, let me do that real quick with common denominators, 5/10 minus 2/10. So that's going to give us 3/10, so 3 pi over 10 is our volume. We'll see more examples with washer method in the next video.